My name is Ted Brady. I'm a field representative for Senator Patrick Leahy. Been working for the senator for about 6 or 7 years now, and I think most of that time in the office I've had the honor to work with Peter O'Dearn from Bennington County Industrial Development Corporation in the back there, and most recently working with him and the senator on exactly what we're all here to talk about tonight, which is the emerging composites cluster here in Bennington County. During the past 24 months or so, Senator Leahy's had the honor and privilege to sit down with Peter, to sit down with Dalton and people at Plazan, both at North America and at Carbon Composites, to sit down and meet with representatives from Vermont Composites, then Vermont Composites, and also with a host of other companies that do business with these larger composite players. And we've talked about what's happening here in Bennington County. It's grabbed the attention of Senator Leahy. It's grabbed the attention of Congressman Welch. It's grabbed the attention of Governor Shumlin, then Governor Douglas. I want to point out actually Pat Menduni from Congressman Welch's office is joining us here. Pat, one more time, because it was too short. And the congressional staffer, I want to make sure the wave gets recognized by the entire crowd. And it's something that's grabbed the attention of the region and the state. As a senior member of the Senate Appropriations Committee, Senator Leahy has also seen what's happening nationally surrounding composites. You see it in the Department of Energy. They are funneling research and development funding towards composite manufacturing processes, towards all sorts of alternative energy and energy components that simply make things lighter, faster, stronger, better miles per gallon when it comes to cars, you name it. He's also seen it in the Defense Department. You see program managers, these are the people that make decisions on what to buy for the Department of Defense, choosing to go for composite materials because they're lighter, stronger weight, they're a better weight, they're stronger against enemy fire and such. In all elements of the federal budget, it's about energy savings, and that is one of the great benefits of composites. It can really deliver energy savings. In the conversations with Vermont Composites and now Cayman, am I pronouncing that right?
Command Composites Vermont.
Command Composites Vermont. The discussions have been about the programs that use composites. So things like aircraft, military aircraft, things like commercial aircraft, saving jet fuel, things like medical instruments. You go down a long list. Composites are in them. When we talk to the people at Plazan, North America, it's talking about armor on vehicles, but also armor on personnel. This is the stuff that our neighbors are carrying around with them in the deserts of Afghanistan, in the deserts of Iraq, and the mountains of Afghanistan. It's about making the entire soldier system lighter and stronger. And you have people here in Vermont doing that work. And what that means is that everybody in this room needs to, in order for this cluster concept that we've been talking about to be successful, we need to embrace it and make it grow. This will not happen on its own. We've been fortunate as a state and in a county, to benefit from what would be organic growth from what then Vermont Composites started by attracting a suitor that developed a portion of their business into a much larger business, brought a portion of their composite business in addition to what they bought, and has simply an organic growth that BCIC has done a wonderful job nurturing, but the state's done a good job nurturing, but we can't stop there or else that's the limit of the cluster. We need to work together to grow a cluster. A portion of the bigger cluster is the actual employers being here. You need to create networking opportunities. You need to create academic synergies. You need to create research and development synergies. And I see a lot of young people in this room. You need to create workforce knowledge and a really strong base of workforce talent that can make this the center of cluster of composites manufacturing expertise in the country. We're fortunate based on the academic institutions that we have just around the corner, and there are some real opportunities here. The state's trying to do their part. BCIC is taking a lead and doing a wonderful job on trying to make sure that this cluster does not dissolve And it's also taking a very big commitment from the companies themselves to make decisions to invest here in Vermont. And the state, the delegation really appreciates what they've done so far. And we hope to help nurture those investments and continue the investments here in Vermont. I will keep it brief at that and just let you know the Senator is very interested in what's happening here tonight. Senator Leahy came, as I said, within the last 24 months several times to Bennington County to talk about this subject in particular, and will continue to remain engaged. But it's my privilege now to introduce our Deputy Secretary for the Department of Commerce and Community Development here at the state of Vermont. That's Pat Moulton-Powell. So Pat, take it away.
Thank you very much, Ted. It is an honor and a privilege to follow Ted and Senator Leahy's office this evening, because the Senator and the entire congressional delegation have been huge proponents of the Composites cluster here and of Vermont business generally. They're very good at helping us make the connections with federal contractors and other players who can support Vermont business. So my continued hats off to Senator Leahy and the rest of our awesome congressional delegation in helping folks know that Vermont's a great place to do business. So thank you all for being here tonight. This is an exciting event in terms of really highlighting the composites industry here in Bennington County, and more specifically, this emerging cluster. This is really an important industry sector. It's an important cluster to us, not just for Bennington, but for the entire state of Vermont. And we want to continue to do our part in supporting and growing the industries that are here, and thanking them for making the investments that they've already made and the continued investments. We have provided direct support and training program and other programs that the agency administers either directly to the three major composites players here in Bennington. Come on, Composites Vermont, right? Am I getting that right? Oh my God. It's still new to me, and Plasan North America and Plasan Carbon Composites. We do that either directly to the company or through BCIC, and Peter Odierna is our boots on the ground here in Bennington County. He's sort of our partner in delivering economic development services here in the Southwest Kingdom. But we also want to make sure you are availing yourselves of the other resources that are available through our agency, and if you'd like to know more, please let me know. But I want to put a shameless plug in at the moment for an innovation engineering initiative that Peter and we are engaged in with companies here throughout Vermont. But it's an opportunity through the Vermont Manufacturing Extension Center to use innovation engineering tools to help develop a pipeline of new products and improved products and services that are offered by companies here in Vermont. We at the agency are providing some subsidy to help smaller companies engage in this process. It's not a short one, but it's an important one in terms of helping companies really look at how can we improve products, how can we introduce new products, doing it quickly, doing it efficiently, discovering whether those new opportunities have a market. It's a fail fast, fail cheap, if you will. Understand quickly what the opportunities are and then quickly deliver that to the market. VMAC, Vermont Manufacturing Extension Center, I know has met with Peter and other companies here. If that's of interest, let us know. But it's those kinds of resources that we want to bring to bear to anyone who's either doing business in the state of Vermont, doing business with composites clusters, so that we can help you create and ultimately grow jobs. So I'm here to listen and learn, but please know that we are very committed to supporting this cluster here in Bennington County and the entire sector and opportunity this presents. We want you to tell us what you need to continue to be successful, to continue to be competitive, and we will do all we can to deliver that. So it's a pleasure to be here. Thank you all for coming and your interest in this important sector, and let's work together to create more jobs here in Bennington County and here in Vermont. So with that, I would like to introduce Kathy Leach, who is on the BCIC Board of Directors and also with Merchants Bank. So thank you, Kathy.
Good evening. On behalf of the Board of Directors of the Bennington County Industrial Corporation, I welcome everyone to our Bennington Composites Cluster Forum. We are pleased to report that here in the southwest corner of Vermont, there is an economic development story to share a story of carbon composites manufacturing growth that translates to job opportunities and economic recovery and stability. We are grateful to our carbon composite experts who have agreed to partner with BCIC to bring this important news to you today. BCIC wishes to recognize and thank Senator Dick Sears for his commitment to economic development in Bennington County. Thanks to Senator Sears, the Bennington County School of Workforce Partnership study generated a technical training program for composites offered at the Bennington Career Development Center. Today, individuals are receiving composites job training, and companies are finding skilled workers ready to hit the ground running. We would also like to recognize and thank Senator Bob Hartwell for his support of BCIC in our region. Both Senators Sears and Hartwell realize that sustainable and successful economic development efforts begin at the community level. The Bennington County Industrial Corporation is a nonprofit economic development entity. Since 1957, BCIC has facilitated many job-creating and job-saving projects. Our board is comprised of business people and professionals with representation in manufacturing, education, healthcare, finance, and other areas. Under the leadership of our executive director, Peter Onierna, BCIC recently facilitated the relocation of 100 jobs from New York State to Manchester, Vermont. In addition to the Career Development Center, the town of Bennington has 3 colleges within its borders: Southern Vermont College, Bennington College, and the Community College of Vermont. These academic institutions, along with the premier medical center, Southwestern Vermont Healthcare, complement the strong manufacturing and business base here. Carbon fiber composites manufacturing will be a catalyst for growth in our region and our state. As the Composites Valley, Bennington, Vermont will be a source of new, good quality jobs and industry with low environmental impact. This expanding revenue stream contributes to a healthy, vibrant economy. And a healthy economy is critical to a healthy, vibrant community. I would now like to introduce James Salerno. He's a design engineer with the town.
Good afternoon. I'm going to speak to you tonight and try to educate you a little bit on what qualifies as a composite, and then more specifically, what is a carbon composite? What does that mean? And I'll get into the benefits and some of the cons of a carbon composite as well, and then I'll speak briefly about carbon composites in the automotive industry today and where they're going in the future. So if you look up here, you see some pretty typical composite applications. You see things like fighter jets, satellites, wind turbines, luxury yachts, but composites are really more basic than that. The only thing you need for a composite material is a material that's made up of more than one distinct part. The example that I have up here, you have a matrix, it could be some sort of epoxy, you have a carbon fiber mat, you combine those together, and you get a lovely dive plane on a Dodge Viper. That's a composite material. The key thing with composites is they're the sum of their constituent parts. You take the benefits and the material properties of the carbon fiber, its tough tension strength, and you take the durability of the matrix and you combine them into something that's greater than the individual components. Here's some everyday composites. Now, I'm willing to bet a lot of you don't own luxury yachts or $100,000 sports cars, but your house is probably made out of plywood and 2x4s. You probably have a concrete foundation. Maybe you ski on the weekends like Brad does, and I hope all of you have brakes on your car. All of these are composite materials. The brakes are a neat example. They have ceramic particles embedded in a metal matrix. So composites really are everywhere. Now I'll talk to you a little bit about what's carbon fiber, where does it come from. It's not something that you really see occurring naturally. And this complicated looking guy behind the coat rack over there is a polymer called PAN. It's one of several precursor or raw materials that we use to make carbon fiber. You take the pan and you heat it up to 3,600 degrees Fahrenheit, squeeze it with some pressure, you shoot it with electricity. Really very complicated. I don't fully understand it myself, to tell you the truth. But what you're left with is a string of carbon atoms. Now, this white strand right here, that's a human hair. And this is a carbon fiber going across it. They're about 5 microns across, very small. Not really useful in that form factor. So what you do is you spin a whole bunch of them into something called a tow. And then you can take that tow and weave it into a fabric, or you can spread it out into something called unidirectional carbon fiber. Now, I hinted at this before. You can see there's several common types of composites here. Continuous fibers, what we do up at Shields Drive at Poisson, and some of the other applications you'll see are short fibers. You'll see those in injection molded components like toys or brackets. And then you have particulate composites, which you'll see similar applications there. Over here is an electron micrograph of a carbon composite. Notice the blue rope-looking things. Those are actually the tows of carbon fiber. And the brown material surrounding it is the matrix that they're embedded into. Again, you can see it's a composite because there's more than one material in it, but they're distinct. They're not mixed together like if you would like a plain epoxy, like some of you maybe are familiar with JD Weld or various epoxies that you can get at Home Depot. That doesn't quite count. It doesn't become a composite until you put something else in it. Now, pay attention. There's going to be a quiz at the end of this. So this graph is very important. Down here, you have carbon fiber. Up here, you have steel. The further out on the graph you go, the stronger it is. The higher up you go, the heavier it is. So here's carbon, very strong, very light. There's steel, almost as strong, but more than 3 times the weight. Titanium is about in the middle, aluminum is right there, and down here you have materials like nylon, wood, and concrete. One of the most significant properties of carbon fiber is that the strength of the material depends on the grain direction. So if you look at a piece of carbon fiber like this, with all the fibers going this way, it'll be very strong if you pull on it in the direction of the red arrows. Likewise, if the fibers are going across the piece, it'll be resistant to stretching this direction. And if you have the fibers going diagonally, it'll be strong against twisting. So you can use this to your advantage when you're designing a part, and you can pull the most amount of weight out of a part as possible. Now, you're saying, okay, great. So carbon composites has all these benefits. Why aren't we using it everywhere? Well, there's several reasons for that. First off, is it's kind of labor intensive right now to make a carbon part. There's a lot of hands-on activity, and there's a lot of training required with it today. But what we're doing up at Poisson is we're implementing new manufacturing techniques and new tools, such as laser ply placement, where you'll have a laser just like this, drawing a boundary where you're supposed to put a piece of carbon. Next up is material cost. Carbon isn't the cheapest material in the world, but a lot of companies are willing to pay because as CAFE regulations get tighter and tighter, there's that much more incentive to reduce the weight of a vehicle. We're also partnering with various government organizations to develop lower cost carbon fiber, lower cost epoxies. So we're fighting it on that front as well. There's some environmental constraints that you have to worry about with carbon fiber. If you go too hot, you need a more expensive resin. So again, that plays into cost. But we're partnering with various material suppliers to bring the costs of those resins down. Finally, there's design complexity. And this is something that's near and dear to my heart because I work with customers every day. We're working to standardize design practices. That's something that they have in aerospace right now, but automotive is still learning. There's a little bit of a learning curve there. Because a lot of these guys come from a world where you take a piece of steel, you stamp it, you're done, it's a part. But carbon, there's a little more to it. So we're working very closely with automotive OEMs to teach them and bring them up to speed. So here's some examples of what you can see on a car today that's made out of carbon composite. There's the Corvette ZR1 right here. It's lovely, isn't it? We make the fenders, the hood, the front splitter around there, and the rockers and the roof as well for this. Right up the hill there at 139 Shields Drive. There are other applications that are a little higher volume, headliners, fender well liners, and where we're going in the future for this, and this has been a press release last year from Plasan Carbon. Our current generation process is 90 minutes to make a part, and we can make just about 10,000 parts a year. However, our new process will take 17 minutes to make a part, and will increase our volumes to 50,000 units a year. And this is something that we've developed closely with our customers, and we are working very closely to bring that technology into a current product. We're also looking to implement more structural parts. And this is what I was talking about before, CAFE, Corporate Average Fuel Economy. All American automakers, and I believe worldwide automakers, is it worldwide? Are required to hit 54.5 miles per gallon by the year 2025. Now think about that for a second. Your car today probably gets what? 15 in my Jeep, 20, 25, maybe 31 on some of the newer compacts. So we have to almost double that. Now let's take into account, a cross member like this. Might weigh 100 pounds if you make it out of steel. You make it out of a carbon composite, you're taking 70 pounds out of that component. For every 10% you take a vehicle's weight down, you'll see a 7% increase in fuel economy. Now that's huge because we can't get there. The automotive manufacturers can't get there on improving engine design alone. They have to take the weight out of the car. And that's a continued commitment and a continued direction that we've seen from them to help develop our own components in-house. Finally, we're doing a lot of advanced research with Oak Ridge National Laboratories and the Department of Energy. We're working on, as I said before, alternative materials. We're working on methods to recycle carbon fiber. If you look at this guy down here, the Boeing 787 Dreamliner, the entire fuselage is made out of carbon fiber. That's a lot of carbon fiber that's going to be going into a landfill at the end of its life. What we're trying to do is take that, recycle it, weave it back into a mat, and put it into a car. We're also working to make improved simulation tools for crash simulation so we can ensure ongoing safety as crash requirements get tighter and tighter. We're working to close the loop on that and reduce development time and development costs. Instead of making 100 of the components that we have to smash into a wall, we use simulation to figure out what are the best 2 components that we can make. And that saves a lot of development time, and it saves our customer a lot of money, and it ensures that a superior product makes it to market. That's all I have. I'd like to introduce Brad Andrews, Training Manager and Director of Product Development, and an all-around nice guy.
I'm Brad Andrews, work for Command Composites Vermont. It's Command without the D. Just in case some of you are wondering, a lot of people have trouble pronouncing that. I don't know why, but there it is. We've been recently acquired. We previously were Vermont Composites. We've been acquired by Command Aerospace Division. It's a really exciting opportunity for us. We're really very excited to be part of a bigger organization, a bigger picture, a lot more exposure to the marketplace. What I talk about today is what's new in the industry. New markets, process, supply chain, and higher education relationships, which are a real important part of this whole composites cluster success that we will have. With the ever-increasing fuel prices, lightweight components make a huge difference, as James was pointing out. Along with that, as material gets used in more and more applications, prices are able to come down more with some of the technological developments that are happening in the materials processes. Prices should come down even more. And as that happens, it's kind of an exponential growth effect that happens. There's products now that are just a little too expensive to manufacture them from composite materials. But if the price point were to come down just a little bit, it opens the door for a whole new host of opportunities. So that's one of the things that makes it a real exciting future for us in the composites world. So we're encouraging our customers, hey, design it with composites in mind, because just to transfer a design from metal into composites, as James spent a lot of time and myself with him, it's an arduous task. We do it right the first time. Just to point out some of the things that are happening in the marketplace. There's two major aircrafts, one of which the Boeing Dreamliner. It shows in this illustration right here. All of these components here previously manufactured by Boeing, ones in red. Now, with the previous model of Boeing 747 and 737 classic, those are both shown there. In the Dreamliner, these arrows point at all various composite components. Many of them are made in the United States, many of them are made in other places in the world, but it's a huge amount of composite components, and that provides opportunity for companies like we have here in Bennington to manufacture components for products like that. A V-22 Osprey is another example. It's about 50% composite materials in the V-22. We manufacture, I think, about 112 or something components in that aircraft. One of the points I'd like to make is that these are two examples of kind of a proving ground for composites in structural applications that have a high level of integrity and confidence in the rest of the marketplace. If it works in a Dreamliner, we ought to be thinking about it as a pretty safe and viable construction method. And companies are, and we're engaging with them, looking for future sales. At Command Composites, we also have a large portion of our business in the medical imaging industry. Composites, they're lightweight, yes, but they're mostly translucent to X-ray radiation, which makes them a really good candidate for patient supports and radiation therapy type applications. In surgical applications where imaging is part of the process in surgery. Some of our competencies that we presently engage in design engineering, we have a strong reputation in the market. We're a really good choice for autoclave care as well as autoclave, full bonding, lots of different things that we do here at Command Composites Vermont. This illustration just kind of shows you of the medical marketplace and the imaging. We supply to various companies that provide product. Philips, Sibco, Mahuzo, Analogic, Logic, General Electric, and others are represented by the 15% slice. So just kind of illustrates, we've got some business from the major players in the medical marketplace. We're very strong there. This is kind of somewhat a simplified version of what James was saying, where composite material is simply two materials brought together to form a product that's got characteristics of each of the component materials. I'll show you some of the processes that are common in the industry. Some of these we engage in here in Bennington, some of these we don't. Those that we don't are under consideration for future products and future processes. Common application here in Bennington is vacuum bagging with pre-preg or wet layup. We use that process here. Compression molding is another one that's done here in Bennington, where it's two match metal tools that are put under pressure by a press and heated for cure. Another method, wet layup, bucket and brush. Used to see it when we used to use fiberglass and polyester resin to fix our cars when they used to rust out before galvanized metal panels and composite fenders. Resin injection molding, or RTM, is another process where you take dry material and you put it in the mold, you close the mold, and then you inject the resin and bleed it into the material to wet it out. Another method of production in carbon fiber is pultrusion, where they basically take a bunch of strands and pull them through a shaping die and a wetting system where the resin is introduced, and it's cured, cure is accelerated with heat, and it's pulled out in a continuous operation, and pieces are cut off as it goes. It requires a cross-section area to be consistent, or the shape to be consistent, like an I-beam, for instance. Another process that's used is filament winding, common in winding cylinders. Sometimes tubes are wound. It's a common method for winding tubes. It's a pretty efficient and fast process. It does require equipment investment, and there's only certain unique applications where it fits. But where it fits, it's a very viable process. The most common technique that we see here today is a pre-preg application. Basically, the carbon fiber is already impregnated with resins. And then the cure is begun at the factory where they put the two materials together. Typically, it's frozen to slow down that curing process. And we store materials in a freezer, as does Poseidon, to continue that slow movement of the curing process forward. When we take it out of the freezer and thaw it, we cut it, put it into a mold cavity, bag it, and then put it in its curing process, whether that be an oven or an autoclave. So this is what material looks like typically in a roll form. This is unidirectional. As James was showing you, all the fibers are running in one direction, and it's in a matrix of what we call B stage, epoxy in this case. That gets pulled out onto a table and either cut by hand or cut by a CNC two-axis cutting machine, three-axis, sorry, where the plows are cut out to shape to fit almost like a puzzle into the mold where the pieces are assembled. Here's a picture of a component that's being assembled, and there's some inserts being put in. They'll be essentially glued in place during the process, and all the layers are stacked in order. Depending on where this part is used, the fibers may be going in various directions to suit the loads that will be needed by this particular component. A call sheet is used in this application so that the backside, where the autoclave pressure is coming on the part, is smoothly distributed across the part, so we get a reasonably good cosmetic finish on the side. The breather helps to distribute any air entrapped in the part out of the part during the vacuum operation. So here's a part with the vacuum bag placed on the mold tool, and the vacuum source is connected up here, penetrating through the bag. The bag is sealed around the tool, so just like those compactors that you buy for, you stick a sweater in it and you seal it in the bag, and it sucks all the air out, right? It squishes down to tiny. Same kind of thing happens here. The vacuum is drawn, and it pulls that bag down and consolidates the material against the mold tools. We check to make sure that the vacuum is good by putting a pressure gauge on it, or a vacuum gauge, to make sure that it's holding vacuum, because that's important. Here's a picture of our larger autoclave. Parts are cured. In this case, that's an autoclave part. What the autoclave part does is it applies atmospheric pressure that's greater than the atmospheric pressure we feel here in the room against the part. It pushes down to the bag, and it tries to penetrate through that bag and out of the autoclave through its vent. But the bag is a membrane that separates the outside atmosphere from the part, and so that pressure results in up to 100 pounds per square inch at times on the part, in all areas of the part, pushing in every direction. So basically squeezes all of the gases out of the part. Hopefully all. These machines are run by a process controller, a little computer basically, and it controls and monitors and reports pressure, vacuum, temperature, temperature during the cure process to ensure that the part receives the cure that was specified. Heat, so kind of in summary, right? The heat and pressure required to consolidate, laminate, and cure the resin, whether it be a vacuum bag, or whether it be a press, or whether it be an autoclave, it's the same thing. It's pressure and then heat to accelerate the cure. Here's the part after cure being torn down, the breather's being pulled off, bag gets pulled off. Here's the part, and it's still on the tool. Here we go with taking the part off the tool. So the call sheet part and the mold tool, 3 pieces shown there. This is just one example. It kind of shows the variety of processes that might be on a given part. Usually the part needs some work afterwards. When it comes out of the mold, the edges are rough. It's in its general form, but it needs some finishing work. So in this case, we're showing the trimming that happens and some holes drilling on the part. Once the part's had its finishing application is done, it needs to be checked to make sure that we got what we wanted and that all the processes happen properly. This is an example of a coordinate measuring machine that uses touch-off on the part that's detected, along with tracking where the position of the stylus is to determine where various features are. And there's a final part ready for shipment. Inserts bonded right in during the cure process, and all the features trimmed as needed. Another thing that's going on here in Bennington, which is really exciting, Poisson Carbon Composites, Poisson North America, and now Command Composites Vermont have composites apprentices. And working with the state of Vermont and the CDC and CCB, a bunch of other organizations, we've put together this training program for composites technicians. And it's really exciting. We have 15 people engaged in the course presently, and another track starting soon, 12 of which are composites apprentices for the 3 companies. They're going through rotation in work through various departments within our organizations. They're attending classes in the evenings, and all working towards a certificate from the state of Vermont in composites technician. It's very exciting. The program is also offered to the general public. So if you know people who are interested in entering this industry, it's a really good way to get kind of a leg up on the competitor applicants that are out there. It shows initiative, and there's measurable skills that will come out of this program that are very useful. For employees who are already employed in the field, it's an advantage in that they're just a more comprehensively trained employee. They know what they're doing. They're able to be a more productive employee. So this course is available ongoing into the future to the extent that there's interest in the community. So if you're a job seeker, or if you're a parent, or if you have friends who are job seekers or parents, let them know this program is in place. Poisson Carbon Composites and Poisson North America, Command Composites Vermont, they're all really good places to work. There's a lot of really interesting things going on there. In my travels in the community, I'm really surprised how many people really don't know what's going on over here in composites, what composites are, or if they would want to work there or not. They just don't know. So you can help us all by spreading the word. Command Composites Vermont looks forward to a very healthy and growing future, as do both Poissons, I'm sure. And one of the things that we need is a workforce that wants to be involved with us. So anything you can do to help to encourage that, that's awesome. Does anybody have any questions? All right then. I'll turn it over to Teresa from Poisson Carbon Composites.
Thank you. I get to do kind of the fun part after following the 2 of them who have explained carbon fiber. I work at Poisson Carbon Composites, and I'm here to represent all 3 companies and to talk to you about why this is an exciting place to be, and to kind of piggyback on what Brad said with regarding the workforce. So the first thing that I want to point out, if it isn't clear to you, is that manufacturing today is not the manufacturing of many years ago. It is not a male-dominated workforce, which is one of the things that we really want to reinforce to you. We certainly want diversity in our workplaces. We value that, and we're here to say, please, kind of embrace that and look at that as you're looking for a great place to work. So we're really looking for more women to enter the workforce, more minorities to work in the workforce, veterans, people who are looking for a second career. Maybe, and I've interviewed folks and actually hired folks that have come to me and said, you know what, I've done all of this other stuff, and I really want to come to work someplace where I can really get my hands on what I'm doing. want to be a supervisor. I don't want to be a team leader. I want to be on the floor. I want to be the boots on the ground doing this kind of work. So it's a pretty exciting place to work, pretty exciting industry to be involved in. And I'd be remiss if I didn't also point out that we're interested in hiring people with disabilities. Again, we're an inclusive workforce. We have room for everybody, and we really want to welcome everybody in the Bennington community to think about our industry as an opportunity to join. So when I was thinking about what else to tell you, I talked to a lot of people on the floor and throughout our plant and the other plants and said, all right, this is what I have to do. I have to talk to everybody about this really cool industry. What is it that you would say to them that would attract them or have them consider working for one of our companies? And I have some quotes that I'm going to share with you in a little bit, but I want to share first some words that consistently came across. It's exciting, fast-paced, always learning something new. In carbon fiber, there are new developments that have numerous applications, and that means numerous opportunities. Opportunities for advancement. It's interesting. It's dynamic. There are exciting implications in the auto industry in terms of increasing standards. And people are pretty excited about the fact that that's something that also touches all of our lives. When we think about career opportunities, we have opportunities for, as I mentioned, the folks that I've interviewed and hired to come in that really want to do more of the hands-on work. We have opportunities for people to get their foot in the door. Some people will come to us and say, you know what, I really want to learn this industry from the ground up. So we have that available. Brad talked already about the apprenticeship program. It has been transforming to see people involved in the apprenticeship program, and Wendy's going to talk a little bit later about the classes that are available. People's lives have changed as a result of the educational opportunities that are being supported here in our industry and in Bennington County. It's really, really an exciting time. We also have tuition reimbursement that's typically available through our companies. And it has also been mentioned that the state of Vermont has programs available for our companies as well as the workforce to take advantage of some of these exciting educational opportunities. So there are really great things happening. The unfortunate thing is the word isn't out there yet. So this is our first step in really spreading that to you all, because we're hoping that we'll see your faces at our door, filling out our applications, really taking a step forward in terms of letting other people know that there is business happening in Vermont and there's business happening in Bennington County. That's a really important message for us to send out because things are happening. So it's our job together to make sure we move forward. Now, I want to touch on some of the areas that people typically don't think about in manufacturing. Of course, there's manufacturing and production. We've heard about engineering. And if you know of anybody who's interested in engineering, there's a shortage of engineers in the state and actually nationally. It's a really important area of focus, and there are jobs available. Supervisors, operators, technicians. Sometimes we don't think about the finance department. Someone has to do the payroll, accounts payable, accounts receivable, all of that budgeting, all of that planning. How about quality? That's a really important department. And quality for all of our industries, or all of our companies, is a critical component of things that we do from the time we step on the floor all the way through. Shipping and receiving, purchasing materials, quoting, research and development we've talked about. How about maintenance? Administration. There are all kinds of things that we need to do to administer so that the really important people who are on the production floor can do their jobs, so that we can be there to support. Human resources, information technology, safety, sales, it goes on, and within each of those departments, there are multiple jobs available. I can't imagine that we couldn't find find a job of interest for everyone, because it pretty much covers the gamut, but we don't think about that. The pay range, beginning level, typically is around $11 an hour, and it goes up from there. And as I said, we have entry-level positions up through professional positions. We have different shifts, there are shift differentials, and our companies do offer great benefits. So that's kind of the broad overview. Now I just want to take a couple of minutes to quote some individuals who work for our companies and kind of their career progression. One woman said, "I've worked in manufacturing my entire career. After being in oil refineries, the paper industry, and electronics, I find carbon composites to be an exciting, ever-changing environment. My current position uses my talents as well as encourages me to expand my skills. It requires me to think outside the box, to find creative solutions to problems. The job challenges me almost every day, and I find that refreshing." Another person said, "I'm really proud to say that I'm part of a team that creates such interesting products together." Another person shared, "I've never worked in manufacturing before. I started as a secretary because I needed a full-time job with benefits. It's been an interesting road and different from anything I've ever done. It's fast-paced, and I learn something different every day." And she happened to mention that sometimes it's great what she learns and sometimes not so much. But she's worked her way up to a supervisory position on the manufacturing floor, and she really didn't expect to do that. But a supervisor noticed her work and asked her to consider a team lead position, which she did, and she got the support to move into that position. She grew from there and is now a supervisor. So sometimes people will come to us with an idea of what their career development plan is and how they want to progress through our various companies. Other times, people won't have any idea at all. And it's the great leadership of our companies that allows our supervisors and other people within our companies to look at the skills and abilities that people bring with them so that we can help them develop that. And that really is happening in all of our companies. It's very exciting. The one thing that this person really likes is that the idea that the work focuses on technique and picking up on things, that you have to have an eye for detail and making that really great quality product. Another person had mentioned that her work experience helped her to advance, that she'd taken additional classes that led to her setting goals to further her education and look at my career development plan or her career development plan at work. That person in particular took some of the classes that have been talked about and will be talked about further by Wendy, and it just really has transformed her from someone who was doing a great job but now has seen an opportunity through further education to benefit herself, but also benefit her company. And one of the last quotes that I have is from another person who said a little bit more about the product. This person works in our quality department. She said it's definitely a much lighter product, easier to handle, and it's neat to see how different things can be molded into different products. It comes in flat, and then it becomes something very different. And she also likes working with a diverse group of people that we have in our workforce, getting to know everybody. The knowledge you gain, she said, is something that is not well known. So you're also part of that really unique experience that you've been hearing about today. So in a nutshell, we're hoping that when you leave here today, you make sure you tell everybody about what's going on in Bennington County, that you consider all of the options available to us, and that you gain some excitement, the excitement that we're hoping we're passing on to you, and consider the carbon fiber industry and our companies as a viable option for employment for you or someone you know. Thank you. It's a pleasure to introduce Wendy Morse from the Department of Labor. She's going to talk about education.
manufacturing, to whatever. And they asked them a couple of questions. What they really wanted to know is they wanted to know what are the challenges in recruiting new employees and what are the challenges in retaining the employees that you have. And what they found was that across the board, those challenges were similar. Employers were really looking for workers who had professional skills such as the ability to communicate, to work as part of a team, computer skills, the ability to problem solve, and really applied academic skills. That was across the board. As a result, Department of Labor and CCD really partnered up and developed something called the Career Readiness Program, which the Career Readiness Program is it's either a 10-week or a 6-week, depending on whether it's a traditional or fast track, and I'll go into that in a minute. That really helps individuals and students develop the skills that they need that are essential for any sort of workplace today. The 10-week course, which is really our traditional, has been running for about 4 years in Bennington. We have a lot of folks around Bennington County that have graduated from this course and have career readiness certificates as well as work keys certification. And I see some of them in the audience today. Yep. The 10-week course really does help individuals build the skills that they need that are essential for the workforce. This one is offered open to the public. It's not connected to any sort of industry. We actually have one that will be starting here coming up February 28th, and we're starting to run some activities around getting into that course. And we also have what we call a fast track, which is really a new concept for us in this area. The fast track is a 6-week or accelerated course that does pretty much the same thing as a 10-week course, only it's really industry specific. In our case, this has been tied around the composites industry and supporting basic skill development for those wishing to take further training within composites manufacturing. The 6-week course is 36 hours of classroom training, and again, it's really geared towards, in this case, the composites industry. So what do students do in the course? The course really affords the students the opportunities to identify their strengths and weakness in both professional and applied academics and improve those skills, preparing them for work and additional training. Students are really taught how to become savvy with regards to resume, interviewing, teamwork, interpersonal communication, and they're really provided the opportunity to develop stronger computer skills. Again, all fundamental to what any sort of workplace needs today. I think one of the greatest kind of side benefits for students to participate in this course and to take this course is really an increase in their confidence. Because they really get to identify and learn a lot more about themselves, the ultimate outcome is that they then become a more confident person. They're then ready, able to take on maybe career advancement within their own organization, or really hit that job search, ground running, and really are a lot more prepared to become employed, or even prepared to take on additional training. They then kind of figure out that, wow, if I could do that, then what else could I do? And that's an amazing thing that we really have. The work key, or the Career Readiness Certificate really provides the opportunity for students to earn up to 2 certifications. One is national, which is called Work Keys, and Work Keys was developed by ACT, the same people that have done the college entrance exams. When we started this program about 4 years ago, 41 states used Work Keys as an assessment tool. Now, every state uses Work Keys, so everybody's on board with it. So what does that mean? That means that as a student graduating from the course, if you get Work Keys certification in Vermont, that is good no matter where you go, what state. Of course, we want you to stay here because this is where the excitement is happening. The second certification that one could get is really a state-recognized certification, and it's called the Governor's Career Ready Certificate. And this was actually endorsed a year ago by Governor Shumlin. And since he has really put recognition among the employer community. So individuals that are walking around with these certifications and they're heading out to employment or upgrading employment within their own organization, it's really looked at as something that's a valuable tool. So why is CRC part of the Composites program? You know, in a nutshell, CRC is really the starting course for the Composites training package. And on the front desk here, and I hope that I see a lot of these go out the door today, there is 2 flyers, one that indicates the entire, gives descriptions of the entire package for the Composites, thank you, the Composites training package, which really, this is all the description. And then the second one provides a schedule of dates and times and all of that, from now right through the end of June, really. The reason why we really wanted career readiness part of this exciting opportunity here is because it really does help lay that foundation for students and really does help them prepare for that next step, which is Composites training, to be that Composites technician. By front-loading the course, the students really begin advanced occupational specific training by having that solid foundation of learning and work skills. You know, the entry point for the Composites training package is career readiness. And if you're somebody in here that's really interested in wanting to get into this course, or if you know somebody, friend, family member, whoever that would like to try to get into it, have them contact Department of Labor. We know all the ins and outs to this exciting project that we have, and we can help them begin the process and getting them into the career readiness course. We actually have one course going right now, and we've got some students here, and I'm excited that they're here today. The next course will be starting March 6th, so there's not a lot of time between now and then to kind of, get yourself ready for it. But there's enough time. So don't delay. If this is something that you are interested in, please contact the Department of Labor and we'll get you in, because we do want to make this, something that is going to be embraced by the community and so that we can fill these positions for the companies that are experiencing such great growth. So without further ado, I'd like to introduce Bob Major, who is the Adult Ed Coordinator, and he can provide all sorts of information about the CDC courses that are available.
I'd like to thank Wendy and all of the actual members of the team that put this program together. You may not realize, but many of the folks in this room actually were part of the planning team. And if you could just raise your hand if you were part of the planning, just to show the folks in the audience that there were many, many people that helped put this together. The Workforce Development Partnership of Bennington County consists of not only the employers you see here today, but also the Department of Labor, Career Development Center, BCIC, CCB, BCRC, the Chamber, and some other members. So I'd like to say thank you to them for the initial planning, and we put together actually some grant applications, and we also received some help from some of the folks on the team in putting those together. The grants that we got from the Department of Labor, we received a $25,000 grant for equipment, which is installed in our lab, engineering lab. Brad Andrews is the instructor for the first course. We also received a grant from USDA Rural Development for curriculum materials, training. That pays for the tuition. The schedule, as Wendy indicated, the CRC components, we've had actually 2 that are funded through the grants. We have some more coming up. March 6th is the next start date. Composites Basics, we have another course starting on May the 9th. Brad has already taught one in the fall. The other components, just to mention those, blueprint reading is part of this, along with inspection and measuring tools. That's a course actually starting tonight at the CDC. Quality in manufacturing, and advanced composites processes. Those are all courses that are funded through the grant. So I encourage anyone interested that has not yet signed on for any of these courses, please contact us, either Wendy or myself at the CDC. It's a tremendous opportunity. We hope to continue this throughout the year. With no further ado, I'd like to introduce our keynote speaker, Dalton Blackwell from Busan, North America.
Well, thank you. I want to thank everybody for showing up tonight. I know you're taking time out of your own personal schedules to be here and to listen to what we do, but hopefully some of the information we've given you will benefit you, and you can take it back, as everybody said, and spread it throughout the community. As a keynote speaker, I'm not going to tell you anything that everybody else hasn't told you. I'd like to first say that, you know, I'm proud to have been a member and gainfully employed by all three of these companies at one time or another. Maybe that's why they chose me to speak here, because I've been in all the buildings and worked with most of the people. Let's see here. If I can get this clicker to turn on, Brad. Okay, so in speech 101, you tell them what you're going to tell them, you tell them, and then tell them what you told them. So that's what we're going to do first here. We're going to talk about the job growth, and then how the composite companies work together, and then new processes for Bennington County. I have a couple. Brad talked about them. There's a couple of them that we're actually going to be bringing to Bennington. And then the composites apprenticeship, and that's pretty important to me because I'm actually a past apprentice and a journeyman tool maker myself. So I went through something similar to this process to start my career. So composites cluster, that's what we kind of like to call it. I think it's Peter's name. I'm not sure. Him or Kobe came up with that, but what the composites cluster is the three companies right now: Command Composites of Vermont, Poisson Carbon Composites, and Poisson North America. So we started out in this 45,000 square foot facility that Poisson Carbon's in, and when I first came to, my first visit to Bennington, Vermont was in 2001. There was 120 employees employed in the composite industry. Now we have this composite cluster, as I said, the three companies making military vehicles, fancy cars for the sports enthusiasts, and then medical devices and aerospace. Currently here, this is kind of why I think we call it the composite cluster. We have Command, and we have Poisson Carbon, and we have Poisson North America, and we have Poisson North America Plant 2. So you can see it is kind of a cluster. There is, you know, the three companies all together, and that's what we've grown into from that time, and from 2001 until 2012, from one facility to these four facilities, plus multiple facilities around the country. I know we have facilities in Michigan, we have facilities in Connecticut, we have facilities in New Hampshire and Massachusetts, but I'm talking about Bennington, Vermont today. And we went from 120 employees in 2001 up here to 490, I think it is, when I talked to the HR managers, all three companies today. So that's a significant growth, even without with the highs and lows in 2006 and 2008 and a little dip there in 2010. We're at over 490 employees employed in the composite industry here in Bennington today. Working together. These three companies are so tightly related that we did work on the MATV. All three companies at one time were producing parts for this vehicle to protect the United States warfighter in 2008 and 2009. Over 8,000 units of different work packages for this vehicle. We're a very, very tight group, and we share information and share people in some cases and processes today. So that's why when I look around the room, I see people I started with and I see people that I work with today. So it is a tight knit area, and we're very happy to be a part of this composite cluster. So on the horizon, let me get to my new products. Pultrusion, I see Brad mentioned pultrusion. That's something that probably people haven't heard, and when you type it in, pultrusion comes up as spell check is messed up. So it's its own word. And we have high pressure pressing composites, and then high level protection body armor. And these are 3 different processes that are going to be either coming to Bennington or here currently in Bennington. So let's talk about pultrusion. It's similar to, as Brad explained, it's great for a constant shape, multiple parts, a long run of multiple parts, and that's why it talks about shovel handles, because your composite shovel handle that you may have that you bought at Kmart or Walmart here in town is most likely a pultruded product, but it's just run and run and run and cut into the right length. Well, we make them into different shapes, and I failed to bring those. If somebody wants to look in my window, there's about a nice little bag of about 10 different shapes that I forgot to bring with me. Well, here's the process. You have a resin package, and you have different fibers, and you pull it. It's pulled through a die to produce a constant shape. So you can imagine, as it's pulled through there, it creates this constant shape, and then you cut that into different lengths and use it within your structure. So it's very good at that. It's more economical than vacuum bag or compression molded, but you can only get a constant shape out of this type of product. These are some stanchions, and these stanchions are made out of composite. There's fiberglass, there's a resin package. This is the USS Carl Vinson, and that's where the NCAA game was played, 11-11-11. If anybody's seen that, Michigan State got beat by North Carolina, I think. Is that right, Don? And these stanchions are on that ship. They're on the George Washington, the Eisenhower, and Ronald Reagan. These are pultruded parts, and so that's an example of a product that was an R&D product brought into production, and we're making them today and supplying these ships with them. And this is a process that should we win other product, because this process is currently in Hudson, New Hampshire, that we would bring to Bennington, Vermont. Body armor. I'd like to talk to you a little bit about body armor. I think this is a pretty important initiative for Plasan and that's for Bennington County and Bennington, Vermont. Currently, the EOD, which is Explosive Ordnance Disposal. Does anybody recognize that picture? Earthlocker, right, that's right. So that suit, the protection for that suit is now, as of last week, made in Bennington, Vermont. We make these panels, this protection panel and this groin plate for that blast suit. It's a high pressure molded product. It is under, I think I wrote it down here, but like 25,000 PSI of pressure. And I think that's a new product for Bennington, a new process for Bennington is the high pressure press. We have existing low pressure flat presses in town, but this is something new that we've just brought in to Bennington. It's not a huge volume, but there are jobs there, and there are products hopefully we can expand from this. The next is personal body armor systems. This is something we've worked a lot on. We had an R&D facility here in Bennington, just a little bit north of Pownell, and we spent the last 3 years developing a body armor product that could be used to protect the warfighter. It's called SAPI, which is a Small Arms Protective Insert, and that's basically what this insert here and this insert here are. We've laid the groundwork for production. We developed the Center of Excellence here in Bennington, and the growth, right now we're waiting on the government to make a decision as to whether they're going to award plus on a major contract, so we're hopeful of all that, that'll come through for Bennington. And then my last slide here, I think, is to talk about the availability of skilled labor in the apprenticeship program. And like I said before, the apprenticeship is near and dear to my heart because I am a journeyman tool maker. And I think it's very important that we have skilled labor here and available. This collaboration of us all bringing this apprenticeship together, this training. Raise your hands back there who's going to school today in one of these classes. We have a few people here. I can't stress the importance of having the skill set to come into the composite industry, be it Command or Poseidon Carbon or Poseidon North America, with that skill set already. It's now starting to be part of the hiring process. Can you imagine how, after you've had a composite class, how much further ahead of the other applicants you become? Because you already know what composites are, you know how to hand layup, you know how to make a vacuum bag. That's very important. And then, like I said, the apprenticeship program, I think we've done a pretty good job of that. Everybody I've talked to, you can read the quotes here, I won't read them all, but there's, the people here are really satisfied with that program. I have not heard a negative yet. Even the long hours of working and then going to night school 2 nights a week, the people still are very enthusiastic and very excited about this program. So in the next couple of years, as we push people through and get their skill level up and bring new entry people in, this is really developing a good base for Bennington County and Bennington for the composite industry. I think that's it. Is there any questions? Okay. Thank you very much.
I'd especially like to thank everybody who traveled down to Bennington to hear this exciting public forum here today. So thank you very much. I just want to say that we would not collectively as a team here put forth the hundreds of man-hours in terms of planning not only this initiative, but planning the workforce development strategies that we put in place if in fact we didn't think that these were real opportunities and if in fact we didn't think that these were great quality jobs. And I'm sort of telling everybody nowadays we don't call them jobs anymore, we call them careers, because I think it was clearly demonstrated here that there is a direct correlation between education and income, and that all these companies participating in this composites cluster are encouraging continuing education amongst their workforce. So we do have time for questions, and certainly if you do have one, raise your hand and speak clearly.
This program, the apprenticeship program, suppose we run into somebody that sounds like a good candidate, where do we send them? What's their first order of business?
Bob Major at the CDC.
Okay.
Department of Labor.
There you go. Thanks.
On anything, what are the drawbacks of this material? And what would the company do in case somebody does have a reaction?
We have personal protective equipment and standards in place in our layup rooms. We require sleeves and aprons at a minimum if employees are coming into contact with gloves, of course, if employees are coming into contact with hot mold tools. We also provide a barrier cream that has been shown to reduce any contact dermatitis that can be caused by handling composites.
Has the process changed over the past year of how you're treating your employees that have had a problem?
I don't think that this is the time and place to air personal grievances. So
Just wondering.
I think that all companies have a very good reputation in town of being good, solid citizens of the community. So we'll focus on the agenda. If there's any additional questions, feel free.
I have just one quick question. Can someone jump into the apprenticeship program at any of the class ranges, or do they have to start from point A to point B?
They really should be starting at point A, which is the career readiness program.
So if they've missed the first
a nice program. Do you have any plans on taking it into the schools for the people that haven't even gotten, or haven't graduated yet?
Yes, the Career Development Center's Composites training program was initially launched at the adult ed side due to logistical issues in there. But it's fully intended that within a relatively short period of time, not only will it be on the adult ed side, but we'll also be servicing the high school age students as well.
It seems like there's a great potential with this material for supporting other ancillary industries who can make use of composite materials. And I know that both of these companies have their focus on their existing customers and they have responsibilities to them. But I wonder if there's been any discussion of kind of a prototyping capability within this company. You mentioned the Innovation Engineering Program. I don't know what that involves, but I'm just curious as to whether there might be a possibility for other entrepreneurs in Bennington County to make use of some of the engineering capabilities at the company to develop other products.
That's an excellent question, and certainly the hope and the goal is that going forward, the composites cluster is going to emerge in a much more dynamic fashion, which hopefully will, instead of having 3 major companies, we'll have more than 3. Plus, more importantly, I think one of the things that we're doing now is really trying to develop the composite supply chain. And we've got some smaller established companies in our community, such as Abacus Automation and Bennington Technologies up in Manchester, that are looking at their core expertise and saying, how can this apply to this industry? So that's happening. Certainly, things are going to change going forward. You know, we talk about how rapidly changing the industry is. And I think by having the spirit of cooperation, really being at the cutting edge of their respective industries that they serve, you know, like I said, the hope and goal is this is going to be much more dynamic going forward.
I can add to that. I know both Lasan and Command Composites Vermont have very active and engaged engineering departments, and we're doing development programs all the time. So, you know, if there's money behind it to do the research, there's people here to do the research.
Full disclosure, I'm here from Rutland Herald. There was all this talk tonight about the opportunities in the carbon composites field. Are all 3 of these companies now hiring?
Lasan Carbon Composites is.
And maybe Command is?
I'm not sure.
And the other question is for Mr. Blackwell. You said about that there's a possibility of a contract. When would you anticipate hearing from that? And is that something you would think that could be handled by the existing workforce, or do you think that would need more jobs?
Well, we've been anticipating this contract for almost a year. So as the government continues to work that way, things are more interesting, but we really don't have a projected date for that. And it would, should we win it, we would require more work.
Sam?
Question, with a limited amount of space at Bennington, are you going to be utilizing existing structures, or in the near future you're going to be putting up a new plant?
That's a great question. I think one of the challenges that we do have is that the industrial real estate market here in Bennington is relatively tight. There are a couple of properties right now that are being leased out, and those leases are scheduled to expire in the coming months. And there's already a line of potential new tenants waiting for those buildings to be emptied. So I think absent of a major plant closure, which I clearly don't expect, I think that over time we will have to introduce additional capacity on the industrial real estate side. And we've spent over the last 3 years a fair amount of money at BCIC preparing our industrial park, the Meneely corporate park, which we named after Dan Meneely, who's really the pioneer of the composites industry here. That's ready to go. That's as shovel-ready as it gets in the state of Vermont. Everything goes according to plan. 45 days, you should have your building approved.
Where is that?
This is currently where Lasan Carbon is located, where NSK Steering Systems is located. It used to be called the Shields Drive Industrial Park, but as I said, we renamed it after Dan Meneely a couple couple of years ago. Global Z, the Memory Clinic, Abacus Automation, they're all up in that park as well.
Susan, Keith, Vermont Public Radio. I thought you had said, or I thought I had been told that there were some spin-offs already of these main three companies that were doing business around Bennington.
Not spin-offs, but they're more the supply chain. For instance, JVM Carmel has been a wonderful partner for Poisson North America over the years. And like I said, Abacus Automation, Matkill Technologies, that's what I'm sort of talking about in terms of the supply chain, which are smaller companies that do serve the needs of the larger, more established companies.
Peter, can I add one thing? Also, Ted Brady from Senator Leahy's office again. Poisson and Command have been very active with the Vermont Chamber of Commerce's Vermont Aerospace and Aviation Association. Chris Kerrigan is here from the VAAA actually, trying to find contractors and subs here in the state of Vermont. So once again, it's a bigger than Bennington County phenomenon. It's really benefiting all of the state of Vermont. They've done an excellent job trying to get work here in Vermont, make sure that their work stays here in Vermont when it can.
Any other questions? Well, on behalf of the Board of Directors of BCIC, all our partners at the table, thank you for coming tonight. I'm certainly encouraged that we saw a lot of young folks here because really what we're doing here in terms of designing these new workforce development initiatives is really designed primarily at you guys. And we're trying to build the next generation workforce to support the composites industry, and you guys are it. So thanks again, and hopefully more good news to come.